service definition file. So service is nothing but it enables the front-end application to be made available for the end users, and it helps the communication between the pods, that mean backend and front-end pods. So we'll write one service with the help of NodePort. There are three different type of services are there: NodePort, ClusterIP, then the load balancer. These are the three in Kubernetes. So ClusterIP by default it was created by the Kubernetes itself, and other two NodePort and load balancer we have to create. So we will create one sample service. I can say I can use sample, yes, okay, .yaml file. So here the attributes are same, some of the changes are there. API version, kind is the service, S capital, metadata. Under metadata you can give your service name. I can give my service -1, and spec here we need to specify the type, the type of service with out of three: ClusterIP, NodePort and load balancer. ClusterIP by default Kubernetes will create. We need to specify the NodePort or load balancer. I'll create NodePort, capitals, capital N, P also capital, NodePort. Then we need to specify the ports which we need to establish the communication. Target port, P is a capital, and we can specify 80, only one space is applicable. And the port, here is the port is the mandatory field, so otherwise it will not work. And NodePort we can mention. So using this NodePort we can access the web service using the IP address along with the IP address. That way we need to specify the NodePort 3008. Okay, that means 30,008. So this is the service definition file. We'll try to run it. So this is the simple service definition file. Save it. Okay, using the kubectl create -f sample sc.yaml file. So the service was created with the help of kubectl get svc. See, so by default Kubernetes ClusterIP it will created, and my service so just now we have created. So we will see another service as a load balancer. We will create one more file, vi load service. I can say load service.yaml. okay, you can specify this the same as it is. API version is v1, kind is service, metadata, that name we can give as a my service -2, and spec here we can mention it as a type as a load balancer, L capital, B capital, load balancer. Check the spell mistakes as well, and we need to mention the ports. Okay, target port, under this we can specify target port P capital 80, next port 80, then NodePort same as it is 3008. So we'll try to execute this as well. So here the only difference is from the load balancer and NodePort is only this type we can mention as a load balancer, and for that NodePort we can mention as a NodePort. That is the only difference. Try to save it and execute it. What is that name? Load service capital L. Okay, port 30,000 private port is already allocated. So it was already allocated. We need to specify another port. we can use loadport.yml file. We can specify 30,009 something. So since the port was already in use, so it will not be allowing. Save it, try to execute it. So map service got created and try to get it. See, my service 1, my service 2, these two are created and the cluster IP is already available. We'll see how the service will work. So we'll try to start the Minikube. So we will see the complete picture about how the service is working. So open this pad. So this is the complete picture about the service and the Kubernetes services. So there are three services available: NodePort, ClusterIP, LoadBalancer. So here this is the node. Within that node we have seen that three ports are available. One is the pod which is running on the IP with the port 8080 and the service in the cluster which is running as 80, and within the node we have this range of 30,000 to 32,716, that is the node port range. So the here what is target port and what is port and what is node port. So target port in the sense port on the pod where our web service is or app is running is 80. Here 80, right? So it is not mandatory field even if you are not specifying. So cluster within the service itself make it as 80, because within the service it will be 80, right? So by default it is making us 80 as a target port even if you are not specifying this 80 port. So even this node port also not mandatory. So within the node port range, any available port it will take for communicating the backend service. So here you can see this port on the service itself. That means within the service itself it has its own IP address. So IP address, this is called the cluster IP of the service. Okay. So then third one is the node port. So port on the node itself which we can access the external web server. This means using this we can access the external web server. This is also not mandatory. The only port is mandatory, that is the service port. So even if you are not specifying both the node port and target port, which is it will be accessible. So once the complete data is available, so we can make the curl request from the command line. So http 92.168.1.9, this is the example, and we are specifying this to 30,009. This is how you can access the external web server. So so how the service will be linked to the pod, that we can discuss now. So clear this. Okay, here we can write one service definition file. vi my service, let me check if any service is available or not. So svc, so there are two services are running, my service 1, my service 2. So let me check what are all the content is available in this one. Cat. So this is the sample service, right? Here we have seen that kind is service and name is my service 1. But in the port range we can see the target port and node port. This three is available under the port section. Only the port is mandatory. So both of target port and node port, even if they not available, so it will be considering by default the service itself. NodePort it will consider any range between 30,000 to 32,767 and port is 80. So it will be taken for the backend pod also. So we will write one pod definition file. So how it will be linked. So we service link, we can say service link, right? Service link.yaml. Okay, here we will write down API version v capital, kind is pod, metadata. Here we are specifying the name. So my service, you can use anything as per your my service 3 I am giving, and labels we are specifying labels app, my app service, and a type front end. Okay, this is the pod definition file, and under spec we can use containers. Okay, hyphen name is nginx, image is nginx. Okay, this the file is completed. So the under the metadata section, labels will be going to the service definition file. We can explain that by going through that file. This is the file, right? Save it, and you can use the cat command to view the service link YAML file. So this is the service link YAML file. Can use vi sample sc.yaml. Okay, this is the service definition file, my service definition file. We can edit this. So here selector we can use ctor, then app, whatever we are specifying previously with the pod definition file, that we can use my app service. Hope this is correct. Later we can check. And type is front end. So this selector labels will come from pod definition file. This is how you can map the service to the pod. Save it. You can compare this one also. So this is the pod definition file, and this is the service definition file. So my app service is there, and my app service is there. So spell mistake, and that is fine. So this is how you can map this service to the pod definition file. So once everything is complete, you can try to use kubectl create -f. Using the pod we can create it first. Okay, so service link dot pod file. Okay, so my app service 3 was created, and then get it kubectl get svc. Because I'm giving the pod, right? Kubectl get pods. Service 3 was running, and now try to get it, execute it. Service definition file -f sample sc.yaml file is invalid. Ports NodePort invalid value provided is already allocated. Okay, so it was already allocated. We'll try to change that. Vi Save it. Now try to run it. That is also running, huh? Okay. So now we will try to change one different port. 30,006 I can mention. My service one is already exist. What is the file name? Oh no, man. So that one we can say my service 3. So until you practice, you will not get this errors. So once the errors will be there, so you are trying to rectify that errors, and you will clearly understand what needs to be done. Okay, my service 3 got created. Kubectl get svc now. Clear. Get svc. So 3 services right now we have. Third one was created, and it is running on the NodePort. Okay, 30,006. Okay, now get the pod. Kubectl get pod. So one pod is running. Hope this one is clear, and this is how I need to mention this, how the difference between NodePort, ClusterIP and load balancer. Suppose if it is a single pod, this is fine, and if in a production environment, so if we have the 3 pods running in the 3 nodes, and the different, those are different parts, each pod is running on a different node. So okay, it is having the IP address is same and port is same. In that case, Kubernetes will clarify, I mean Kubernetes will be identify which port is running on which node on the pod, and it will be share the load across various pods. So we are not doing anything on this, and Kubernetes, I don't know what algorithm it was using. So the Kubernetes itself, it will identify and distribute the load across the pods on the nodes. Hope this is clear.